All right, here are solutions for quiz 6 from Math 213. This first problem, you're asked to determine the volume of I guess, regular square-based pyramid with all side lengths equal to 2. Okay, so I guess you need to know a few things. The first thing is that the formula for the volume of any pyramid is 1/3 times the area of the base times the height. And in this case, the area of the base, A equals area of base, which is pretty easy because our base is a square and all side lengths are equal to 2. So the area of the base is equal to 4 units squared, I guess, if you care about the units. Unfortunately, much more challenging is figuring out the height. So to figure out the height, it might help to draw a picture, although that's not the easiest thing in the world to do, but I'll give it a shot. So here is my kind of square-based pyramid, and there's a line kind of hidden from view back here. Similarly there. Sure, good enough. So I have the square-based pyramid here, and I know that this length is 2, for example, and that this length is 2 right here. But really what I'm looking for is the height. Maybe I'll pick other ones so these don't roll together too badly. This is 2 and this is 2. What I'm trying to find is the distance from right here to right here. That's going to be challenging to find. I think the easiest way to go about it, or at least one way to go about it, is to first find the slant height. So the distance from right here to right there. Maybe I'll label that with a kind of cursive L for slant height because that's what we've been using in class. And then I'll label this guy in red with an H for the height. And the challenge is neither of these are that 2 that is given. However, with the given information, I think we can figure it all out. I think we'd first figure out L. So let's draw that triangle. I have an equilateral triangle because all side lengths are equal to 2. So this is 2 here, this is 2 here. And what I want to figure out is this length, which is L. And I could take advantage of the fact that I have a right triangle here, so I can use Pythagorean theorem. This length is 1, half of this 2. So 1 squared plus this weird cursive L squared is equal to 2 squared. So 1 plus L squared equals 4. L squared is equal to 3, and therefore L is equal to the square root of 3, which if you feel like getting a decimal approximation 1.41 something, you feel free. I'm going to leave it like this as an exact answer. Unfortunately, that doesn't answer the question. It tells me this length right here. What I want is what's in red right here. But I can get from this answer to what's in red by drawing yet another triangle. And so let me try to do that and color code things properly. Here's H, and here's L. And then kind of right here is connecting this point. I need another color, I think. Okay, super light green, I guess. Connects these two guys here. I'm going to go through all this trouble of color coding, and then I'm going to print these things in black and white like an idiot. Okay, so with this information, I think we can figure out everything we need. I know that L is the square root of 3. It's an odd color choice. Let's go back to green. From above here, H is what I want to figure out, and this little neon green guy, I'm not going to find that color again, is 1. And the reason that's 1 is the distance from this point all the way across would be 2 because it's parallel to this line. So halfway across from the base here to here would be 1. So I can use this to solve for what H is equal to. I got 1 squared plus H squared is equal to the square root of 3 squared. So 1 plus H squared is equal to 3. H squared equals 2. I think I said this was 1.4. That's a lie. This is 1.7 something. This is 1.4. H is equal to the square root of 2. Once you have H, you can finish up this problem up here. I can say that the volume is 1/3 times A, which I determined earlier to be equal to 4, times H, which is equal to the square root of 2. In other words, you get 4/3 or 4 root 2 over 3. How about that? You're like, no, I did this whole thing with decimal points. I want to know if my answer's right. Well, don't worry, I got you. We'll pull out a calculator and figure out just what 4 root 2 over 3 is equal to. So 4 times the square root of 2 divided by 3 gives me this 1.8856. And I don't care that you show that many decimal places. And if you care, this is volume, so it would be units cubed. Because I can throw a box around that and call that good. Move on to the second problem here. Second problem I think is a little bit easier than the first. I thought that first one was pretty hard. I thought figuring out the height was really challenging. The second one says, what is the volume of the largest cylinder that can fit inside a cube of volume 8? Hint, the base of the cylinder will lie flat against one side of the cube. Okay, it might help to draw a picture. Here's a cube. Guess that's the base of the cube. This is all in the background. And this is up in the foreground. As is this. And this. Alright, so there's a cube. Not a bad looking cube if I do say so myself. And then I got a cylinder, and one side of the cylinder will lie flat against one side of the cube. So basically what's going on here is I'm talking about, what's this strange looking circle? That's what I get for bragging about my drawing ability on the cube. I don't know if I actually said that out loud, but I was at least thinking that that was a damn fine looking cube. Anyway, here's my cylinder. You can kind of see this guy is inside this cube right here. Okay, so if the cube has a volume of 8 centimeters, I guess really these are centimeters cubed, what that means is the side length is equal to 2, I guess centimeters in this case. And so what that tells me is that the height of my cylinder is equal to 2 centimeters, and the diameter of my cylinder is also equal to 2 centimeters. So when I'm trying to figure out the volume of my cylinder, the formula for the volume of the cylinder is really just a special kind of prism. So I take the area of the base, which is pi r squared, and I multiply that times the height. So I have everything except for r. If the diameter equals 2, then the radius is equal to 1. So I take these numbers and I plug them in over here. Pi times 1 squared times h, which is 2, gives me 2 pi. And if you care, these are units. No, they're not. They're centimeters, I guess. Centimeters cubed, because I'm talking about volume. And this is equal to about, let's see, pi is 3.14, so we'll call this 7.28 maybe. And I don't care if you give me the exact answer, stating it in terms of pi, or a decimal approximation. Either way should be good. And I guess I could label this a little bit better if you want. We call that H. Kind of call that R. Fine, good enough. All right, so I guess that ends this video.